Okay, we're going to start here, I think. How many people do we have here? 17. We still got a ways to go. Hopefully everybody else will come, but it is time to start the class. So, welcome. It's good to see all of you. And hopefully, yes, some more people are coming in. Good. So this is SCMP, Scientific Computing 118, Introduction to Programming. I am Professor James Scahn, and I'm your instructor in this course. So it's good to meet you. It's interesting looking through the data. It looks like about half the class is on campus and the other half of the class is remote. That's one of the reasons why we're teaching this course remote, is because it turns out that way we provide the service to people who can't be on campus now. So, welcome back to campus, those of you who maybe weren't here in the fall. I'm on campus some. I'm actually teaching from home today. Most of the time I'll teach from home, but sometimes I'm on campus, but welcome. Let me go ahead and share my screen and we can kind of get off to a start here. So I'm going to start out just sort of by talking about myself a little bit, just to give you some background so you know who I am. And I do that because I want you to know who I am, and I want to get to know you. And I hope by me opening up, maybe you guys over time in office hours and other opportunities, I'll get to learn more about you. And there was a form that most of you filled out that I'm going to show you in a bit. And I hope everybody fills that out, and there's an opportunity for me to tell you about yourself. And I've already read about many of you, and I've enjoyed doing so. And so a couple things about me. One cool fact about me is my child, Luca, is a 2013 physics graduate and is in computer science. In fact, Luca is a PhD candidate at the College of William and Mary and is working in quantum computing, which is something I don't even know that much about. And so I think that's kind of cool. I have a PhD in computer and information science from Ohio State University. My PhD was in computational linguistics and artificial intelligence, and actually also in database design. And I worked on a thesis where I studied the use of sort of sociological information to help understand language. And so good old OSU. Some of the things that I have done, I've spent a lot of my career doing research in wireless networking. And in fact, my students back in the 1990s and early 2000s, we actually worked on a project with a company that my best friend owned. And one of the things we did was we created the first Wi-Fi device and licensed it. That's the one on top, is Lucent's Wi-Fi device. Another version of it was later licensed to Apple, and that was the first Apple airport that was sort of revolutionized the world and introduced Wi-Fi to the home consumers. That was the first Wi-Fi device, and it was pretty cool because we made it. And the funny thing was when we made it, we didn't know we were making it for Apple because the contract specified we weren't allowed to know the name of the customer who was buying our wireless Wi-Fi stuff. And then it turned out it was Apple. When Steve Jobs came out on the stage to introduce it, it was like, yeah. And I've developed protocols for various Wi-Fi stuff and various networking, including long distance networking, where you go miles, many miles, instead of just across a room. Another project I've worked on is, believe it or not, an online system for mentoring couples in their relationships. And so it's basically an adaptive learning system where people interact with the system and with a coach, and it helps them understand things about their relationships. And I didn't build the curriculum, I built the platform that runs the curriculum. I also work with Professor Snipes and have worked on a project where we look at Euclidean embeddings of snowflake metric spaces, which probably doesn't mean much to most of you, but I wrote a visualization program which we're looking at, whereby we could look at these interesting mathematical phenomena. And then actually we can go deeper and deeper. So here's at one level, we can go deeper. And what I've been actually working on this past year is I've been working with an operating system called FreeBSD, which probably nobody's ever heard of in this room or in this class, but it's actually widely used on the internet to run the internet backbone. And so I've been working on that operating system, trying to optimize its networking performance under certain circumstances, specifically when we put it on machines with high numbers of processor cores. And so this summer, we're going to be exploring the use of these speed ups on AMD's new Ryzen chip, which has 64 cores, which whether that means anything to you or not, I don't know. We'll learn more about that in this class, but it turns out most computers either have 2 or 4 cores. And so I have a student that I'm going to be working on that this summer, and hopefully more students in the future. Another interesting thing I do that I haven't been able to do last year or this year, sadly, but for every year for like the last 15 years, I've taken students to Central America in Belize and Guatemala, and most recently we've been building solar power systems for schools. And I do that in collaboration with Professor Alexander in the Environmental Studies program. Okay, so that's just to sort of give you a little background on me. And again, I want to hear more about you guys, and so hopefully I will. Now, one of the things that we're going to be doing in this class, and I'm going to be getting into more specifics in a moment, is we're going to be doing a lot of group work, a lot, okay? And I think you'll like this, right? Because you won't have to hear me talking for 80 minutes. Instead, you'll talk with each other and you'll learn together. And so it's important, though, if we're going to work as groups, that we do it in a way that's effective. And what are some things we want to think about when we're doing this? One thing is to be present and fully engaged, right? If your teammates are doing your work and you're just sitting back and watching, you're not doing yourself any favor, because you're not learning. And you're also sort of letting your teammates down. And so be present, be engaged. And remember, everybody has something to learn. You know, you're going to have people who've had more in the background or less in the background, but you all have something to learn and you need to work together. Everybody has some perspective or some expertise to offer. Help others do things for themselves. In other words, don't do it for them, help them do it themselves, so that everybody learns how to do what we need to do, because that's the goal in this class, that we all learn how to do programming. We're a community of learners, right? We are together, we're in this together, and we're going to learn together. And we need each and every person in this group, and we'll be talking about that more, but nobody is extra. Nobody is just sitting out. Everybody is participating and working together. That's really important. Now, we want to learn, but we want to learn effectively, and we'd like to have fun. No reason it can't be fun. And so again, if we're engaged, we're more likely to enjoy it, and we're more likely to really learn. Take ownership of your learning, right? Our learning is your responsibility ultimately. It's not mine. I'm going to do my best to provide you with opportunities to learn, but I can't make you learn. You have to position yourself and actively engage in the process of learning. In this class, you need to study regularly. There's a lot of outside class work. There's a lot of reading. And if you do that, you're going to be okay. And if you don't do that, you're going to get behind and you're going to be really frustrated. And everybody can do this course, but it takes regular engagement, right? And along this lines, I want to remind you guys, don't hesitate. Don't feel like, oh, I'm so lost, I don't even want to talk to the professor. No, that's exactly when you do want to talk to the professor. I'm never going to look down on you for coming to me and saying, I just don't get what I'm doing here. That's what I'm here for. So study regularly and then use that knowledge. Again, I guess I sort of jumped ahead, but seek help in a timely manner. When you run into problems, come and get help before it's too late. Don't wait till the last minute. Come to talk to me, come and talk to the student helpers. Form study groups is a great thing to do. You're totally allowed to do that. Come and see me often. Please, I want to see you. That's what my office hours are for. I've actually have 8 scheduled office hours a week. So there's plenty of time for you to come and see me. And don't play the catch-up game. Getting behind and then catching up is horrible. You know, one thing I learned early, I learned when I was a first year, just like many of you guys, I learned that the best way to especially to write a program was, you know, the moment it's assigned to start working on it. And, you know, if you get it done early, great. But you might run into problems. And if it's due the next day and you run into problems, you panic, you don't have time to think about it, and you just get stuck. But if you work on it, and then when you get stuck, you take a step back, go eat in the cafeteria, work on something else, go for a walk, you come back, and then it makes sense oftentimes. So you need the time to get it done, and you just can't cram it in. All right. So is there a tutor here today? Sometimes I think, is Dave, are you?
I'm here, yeah.
Yeah, okay. So we have 2 tutors. One of them is going to be helping us on a regular basis, Dave and Sejin, and they are available for you as well as me. You should never go for want of help, okay? So I'm available. I'm going to show my office hours in a moment. Here's the time in which Dave and Sejin are available, Sunday, Tuesdays, and Thursdays. And again, there's a link. When I get to the syllabus, I'll show you the link to all this so you don't have to remember it. But Dave, you want to introduce yourself and talk a little bit about yourself?
Yeah. So I am Dave, and along with Sejin, we would be your MSSC tutors for this semester. So for those of you who don't know, MSSC is basically a resource for you guys to use outside class and outside office hours. So if you need an outside someone else's opinion on your code, or if you're stuck with anything, don't hesitate to come to the MSSC. This year, this semester, the MSSC will be remote. So we will meet via Zoom again.
Mm-hmm.
It's usually during Sundays, Tuesdays, and Thursdays. Our timetable is in the link that Professor Scott will later give you. Also, we'll be starting this Sunday. That's 7th of Feb. So I hope to see many of you there.
Yes. Yes, please use Dave and please use Sejin. They're both very knowledgeable. They've both taken several computer science courses, and they've tutored before. They tutored last semester, so they know exactly what goes on in this class, and they can help you. By the way, Dave, we do have a few new projects that you haven't seen before, but you will be learning about those. But most of the projects you've seen before. I changed a few of them. Okay, so the next thing I want to show you guys is the syllabus. And the syllabus, in order to get to the syllabus, and I hopefully you got an email, most of you, some of you came into the class late and probably didn't get this email, but most of you did. If you go to cs.kenyon.edu, very easy to remember. Of course, I have to spell Kenyon right. I missed my N there. Come on. And this takes you to a page with all the classes, computer science classes in there. And we can see right at the top of the list under spring 2021 is this class. And you see there's actually 2 sections of the class. And they're basically identical, even though Professor Iden teaches one and I teach the other. We have the same curriculum, we have the same syllabus, we have all the same assignments. And so you know, although I don't want you to just do the, you're not allowed to do this just because you feel like it, but if some emergency occurs and you can't go to this class, it is possible to make arrangements to go to the other class. And so keep that in mind. And that's especially easy, of course, because it's a Zoom class. It's not like we run out of chairs. And another thing to note is that we record the classes and post them. So you can go back and review the course. Okay, here's the MSAC schedule. Here is the website, and here is the Zoom information here. I'm not going to click on it right now. Here, of course, is the Zoom link for my office hours. Sorry, for the class, and a Zoom link for, probably should make this bigger. Zoom link for the office hours. My office hours are 1 to 3, Monday and Wednesday, 8 to 10 on Friday, and 1 to 2 on Tuesdays and Thursdays. So I have an hour shortly before class on Tuesdays and Thursdays. Anybody have any questions on anything that I've talked about so far? Okay. Okay, so, just in general, I'm not going to read through this, but this is a general introduction to computing and computer science, but mostly focusing on programming, but we'll learn a little bit more than that. And so we want to learn how to do programming. One of the things is we're going to actually learn 2 programming languages in this course. We're going to focus mostly on Python, but then toward the end of the course, we're also going to learn a second language called C++. And both of these are very popular languages and used a lot. And so they're good languages to know. This course has 2 texts. I actually have 3 lists here, but there's 2 primary texts. Now, the nice thing is these texts don't cost you any money. They're completely online, and they're even interactive. They have programs built into them that you can run and try out, right? And not only that, when I give you reading assignments, I can actually monitor if you've read the material and if you've done the problems. And so that's part of what you're expected to do. So you'll get regular assignments reading out of these. Now, these are, you actually, in order, of course, for me to monitor them, you actually have to join these classes, okay? And so there's actually 2 classes. There's mine and there's Professor Iden's, and we actually did those separately. And so don't worry about the C++ one right now. We'll worry about that later in the course. But if we click on this link, actually, let me log out. You'll see something like this. And then what you can do is, I've got to remember, sign up, okay? When you sign up, you make up a username and make up something reasonable, not something crazy, because I want to be able to know who you are, something that has your name in it. First name, last name, your Kenyan email, please, a password that you make up, and then the course name. And then what you're going to do for the course name is you're going to copy the course name here, because it's long, and paste it in here, and then agree, and then you're going to sign up for the course. Now, when you sign up for the course, what'll happen is, now I have a lot of courses here because I've taught this a lot. You're going to see the course, and you'll be able to go into it, and you see it's a table of contents of a book. And you can go through, we'll pick something a little further along here. If we go into selection, Boolean variables and Boolean expressions, notice there's a video in here. There's stuff you can read. You should watch the videos. Now here's a program, and I can run this program, and here's the output. I can actually change the program. Like I can do something silly here, print Kenyan, and run it. And notice Kenyan now appears down here. And notice there's two versions. I can see the original version and my version. In fact, I can make another change, print and run it. And again, there's three versions of it now. So you can actually do programs, and you should do programs while you're reading the book. And then you could, when you read a page, you mark it as completed and go to the next page. And then you go through and do those activities, mark as completed, and go to the next page. And then I can actually see what you have read, and I can see which problems you have completed, okay? And so, mostly people have been pretty happy with this textbook. I've been pretty happy with it, but it is important that you read this book, but it's not like a regular book, which is amazing that it's nice and it's completely free. So, because you know how much you can spend on books. I don't have to tell you that. Okay, any questions so far? So that's how you, and again, later in the course, we will sign up for a second book, but you don't need to worry about that now, although the information for how to do that is in here. I just don't want to waste time talking about that now because we're not going to need it for a few months. Now, this course is going to have a lot of group activities, as we talked about. We're going to use a process called POGIL, process-oriented guided inquiry learning, which is a nationwide sort of trend, if you will, where educators, specifically educators in the sciences, have adopted this very specific process for having a group interact with each other effectively and to basically work and discover, okay? So oftentimes you'll do something and I won't explain what you're going to do before you do it. I will give you an activity and then you're supposed to try it, and there's an expectation. You shouldn't say, well, Professor Scon didn't tell us exactly how to do it. That's part of the point, right? You're learning by trying things out, seeing what works and what doesn't work, and then trying to make sense of it. Okay, so it's a discovery process. And I lead you through a series of activities, right? And so we're going to be learning about that today. And we're actually even going to do a POGIL about POGIL to learn about it. We have lots of individual activities. We have laboratory assignments, 8 of them, which are programs that you run. We have lots of little programs that you solve. And the nice thing about these are they're online. You go in and write a program. If you think you got it right, you run a test and it tells you whether you got it or not, and you can keep trying until you get it right. And so there's like 150 little problems like this that you're going to be doing to sort of refine your skills. The homework assignments are mostly the textbook, right? Those little problems you solve in the textbook. And then there's history essays. We'll be talking about that in a second, but about 10 times through the semester, you're going to write a short 200 to 300 word essay about some historical fact in computer science. And again, I'm going to show you a little bit more about that in a moment. Course attendance is essential, right? And, you know, so here's the thing. In class, we do our POGIL group activities and you get a grade. Usually it's 100. If you do it, it's 100. It doesn't matter if you got it quote right or not. The point is that you did it and you get a grade for that. If you skip class, you don't get a grade for that. You're not allowed to make it up. And well, you're allowed to do it, but you're not going to get credit for it if you skip class. And so that's going to count against you. So you need to come to class to get credit for that class's activities, unless you have an excused absence. If you have an excused absence, then I can work with you and let you do that. Again, we're using POGIL. Now, we're going to learn about it more, and so I'm not going to talk about it right here, but there's lots of information. I'm going to let you learn about that, so I'm not going to talk about it more because we're going to do POGIL with POGIL, and so it's going to sort of be discovering orientated. Here's our textbooks again, our online resources. The other online resource that we're going to use is something called REPL.IT. And I believe everybody in the class has received an invitation, and that's how you get into this. You have to join the class or you can't see and do the problems, okay? So if you didn't, you know, search your email for REPL, and if you don't see it, send me an email and I will send you another thing. You probably got it. Some of you have already accepted it because I can see that I can see when you guys come into this, and some of you haven't, and you have to accept that because that's a big part of your grade. Doing these problems, you get course credit for doing these problems, and we'll be learning more about that later. And you know, but the bottom line is that this is an environment where you can program. This is Replit right here. We're going to be using something called Teams. We're going to be starting out in this class, SCMP118 Python Spring 2021. And inside that team, there's problems that we do. And these are the problems here. And we solve the problems and then we get credit for solving the problems. Okay. And so again, we're going to learn more about that later. I'm just kind of giving you an update. Okay. Now, assignments. Assignments are due on the as specified in the grading table below. We're going to talk about that in a second, but they do have due dates and you're penalized for not getting things in on time. If you miss a lab assignment, it's really bad. There's only 8 of them. And let me just go down here and show you. Here's all of the things you get graded for. And notice the labs are 40% of the grade. You basically can't pass the course if you don't do the labs. So you got to do the labs. Collaboration and academic honesty. I want to talk about this for a little while. Too often, I've had to submit students' names to the AIB for cheating. Cheating oftentimes comes in 2 forms. People share their code with each other, or people go online and find solutions to a problem and they turn them in as though it's their own work, like plagiarism, right? Any use of anybody's work without attribution is pure and simple cheating, right? And of course, so here's the rule. You're allowed to talk to each other about the problems. It's right. You can go out of class and you can say, hey, what do you think about that new lab? What kind of strategy are you going to use? I'm thinking about doing this. What do you think kind of approaches we need to take? Perfectly acceptable to have conversations like that. However, copying, having somebody send you via email or something, or you looking at their solution and then typing it, that is out and out cheating. And it's actually pretty easy for me to discover, right? I've been doing computer science for a long time. And when I see a program, it's like a fingerprint to me. And I can look at one program and look at another and say, boy, that is too similar. In fact, I have a program I can run from Stanford that will actually find correlations between programs. And I've had to use it in the past when I've had groups of students who've decided to share code with each other. Please don't do that, because then you go to the AIB and it's really not a good thing to have happen, the Academic Infractions Board. So the good rule of thumb is the cup of coffee rule, we'll call it. After discussing a problem, you should, it's bigger yet. You should not take away any written record or notes of a discussion. Go have a cup of coffee or cocoa, read a front page of the newspaper. If you can still recreate the problem solution afterward from memory, you have learned something and are not simply copying. Now, of course, assignments that are designated as group work are exempt from this because they're intended to be done together. They're not, of course, exempt from copying online, I mean. So, turning in code you did not write is cheating. You should never receive code from other students, use code from the internet, or use instructor solutions from past semesters if you somehow encounter them. Any code you submit must be entirely written by you. Likewise, facilitating academic dishonesty is a violation of academic honesty. Sharing your code, so if you give your code to the other person, not only do they get in trouble, you get in trouble, right? If you suspect your code has been used, you should report it. And sometimes people steal code and you don't know it. But in fact, that happened to me when I was a first-year student. I turned in a program that I'd worked really hard on, and I got it back, and I got a F on it. And I was like, what's going on? And I walked into the professor's office and I said, why did I get an F? And he said, you cheated. That's not the way we do things at Kenyon, by the way. And I said, what? And after some investigation, it turned out that one of my classmates had pulled a printout out of the trash can and typed my program. So I got my A restored, but it was not a pleasant thing. So my point there is you shouldn't make it easy to cheat off of you. Okay, so here's the thing. By default, all programs you create on REPL are public, okay? Now, if you're creating a program within the Teams thing, that again, I'm gonna show you more about this, it's private, but you have your own REPL account, and if you're using your own REPL account outside of Teams, other people can look at your code. You need to make sure that they don't do that. There's two ways of doing it. One is to only program within Teams. The other is if you pay $5 a month, I'll show you this, you get a version that allows you to set things to private. I wish they didn't charge you for that, but it's not a lot of money. Any questions? I get through all this? Okay, we're making progress. Computer history assignments. So once a week, you'll turn in a brief essay on some computer history fact from the Computer History Museum timeline. Computer History Museum's really cool. It's out in Mountain View in California. I went there a couple of years ago, and it was actually really fun. Because remember that wireless access point that I showed you that looked like a flying saucer? They had one there. And so it was so cool to go into a museum and see something you helped make in there. But also kind of made me feel old. But anyway, so you can go into the timeline. And when you're in the timeline, you can pick an era, like the 1940s, 1963, and you can look down through and find different things. And if you like this, if you want to, if you find something you like, you can then Google it and find out more information. So that would kind of that would be your process. Find something that interests you, then look in Wikipedia and other places and gather more information. So one of those do a week. And the way that works is, like, for example, on February 9th, you're supposed to do one on the 1930s. On February 23, you do one on the 1950s. So you pick something in that era and write an essay, okay? So the essays are due by class time on the day assigned, not accepted late. POGIL activities are essentially due in class. We'll talk about that in a moment. Individual labs are always due on the particular date by midnight. 5% penalty for up to 12 hours late. One assignment may be up to 24 hours late with no penalty with instructor notification. So you get the ability to ask for an extension on one lab without any reason. Homework assignments due by class day. You need to do the reading and the problems by class time. REPL problems, those are due by midnight on the due date. Now, the unfortunate thing about this is they recently changed REPL, and it used to have the times when they were due inside of the program, and they took that away, and I'm really upset about that. But you'll see in here REPL problems in the calendar, and you're expected to do it by midnight on that day. Again, I realize you don't know what a lot of these things are, but I'm going to be showing you this over today and Thursday. And then fun, at the beginning of every class, almost every class, there's going to be a quiz. Now what I do is I open up the quiz 10 minutes before the class. If you zoom in, you'll see the password on Zoom. Then you type in you click on the link, you go to Moodle, and it asks some questions, and you have depending on the quiz, you have a certain fixed amount of time that you have to take that quiz. You gotta be at the beginning of class. And by the way, if you come to class late and you miss the quiz time, you miss the quiz, and then you get a 0. So that is but on the other hand, if you come a little earlier, you can actually get the quiz done, save a little bit of time at the beginning of class. I realize not everybody can do that. So I'm not requiring you to come early to do it. I'm just saying we open it up before, and then you take the quiz, and then we move into the topic of the day. Each quiz will include questions from the previous class as well as on the content of the reading assignment for that day. So there's going to be a quiz on the 4th. So when you come to class, you'll see, when you join class, you'll see a screen that will have the password on it. And then you click on this link, go into Moodle, type in the password, and take the quiz. Okay? And then you have a limited amount of time to take it. From when you start it, there's a certain amount of time, and then when that time runs out, you're done. So then that brings us to the schedule. Here is the complete schedule of the course, what we're doing on every single day, right? The date, the topics, the reading, didn't have a reading for today, any sort of links to other things that we're going to be using that day, slides for the day, that's where the slides were at, And I will post videos here of after class, obviously not before the class because it won't be made yet. And then any sort of assignments that are due are over here. And typically, like for example, the assignments go to another page that tell you how to do the assignment. Okay, so it's all online, it's all here. Okay. So let's try, are you guys ready to try to do a group activity? You tired of hearing me talking yet? I am. Okay, so here's what's going to happen. What I'm going to do is I'm going to divide us up into groups of 3 or 4. I would like every group to be 4, but I can't make every group 4 unless we're a multiple of 4, right? So everybody, it's either going to be 3 or 4. And what's going to happen is each of you is going to pick a role. And I don't need to talk about this too much because this is in here. You're going to be a spokesperson, analyst, facilitator, or quality control. And you're going to learn about those. I'm not going to talk about it. But what I want to say is that we're going to learn about these roles. So here's a link that talks about the roles. Now it's possible that you only have 3 people, but there are 4 roles. If there's 3 people and 4 roles, one person is going to be both the facilitator and the spokesperson. Again, don't worry about it. This is in here. So here's the thing. POGIL process, I'm sorry, POGIL activity 1. This is the key. Now don't open this up yet. I'm going to open it. But this takes you to a Google document that you can't change. But what you can do is you can make a copy, okay? So what I want you to do is to go in here. I want the facilitator to go in and make a copy, okay? Once they've made the copy, I want them to click on the share, and each of you should send your email addresses to the facilitator so they can type the name in, right? So here, this is my wife. I can share it with my wife. And I want you to share it with your teammates and share it with me. And Dave, if you put your email into the thing, save it with Dave as well in case he wants to look at it. So then once you've done that, you can work on the document together. Okay, because I want there to only be one document per group, and that document is shared with me, and then you will receive a grade if you've done the work as a team. Okay, so that's what's going to happen. Any questions? I mean, there probably are some questions, but if you're saying, I don't know what I'm doing, that's probably okay. If you understand what, you know, the only thing you need to understand at this point is that you're going to open up this document, you're going to share it with your team members, and then you're going to work on it together, and you're going to share it with me. Okay? And so let me stop sharing for a minute. Sorry. My dentist was calling. All right. So let me go and see where the breakout rooms are. There they are. So breakout rooms. There we go. Oh, we got exactly 4 per room. So I'm going to create rooms, and then you're going to go into those rooms. Okay, you'll accept that. Open all rooms. There we go. See you in a bit. I'll be coming around. And this is 20 minutes.
Sorry, I don't think I got a
Let me see. Yeah, you're in room 6. You see something there that says join the room?
I don't.